This is number 11 of section 3.2. The following data represent the weights of a random sample of 50 candies. So those are all the weights of 50 candies. If you open the data set into StatCrunch, all the 50 numbers was loaded into your variable 1 column. And because the question is asking for sample standard deviation, you go under Stats, Summary Stats columns, click the variable 1 in. The variance and standard deviation here is actually your sample standard deviation. If you want to find out the population standard deviation, make sure you scroll down and find the unadjusted variance and the standard deviation. Those are for population standard deviation. But for here, we're only looking for the sample one, so we're okay. So click, you will see standard deviation. The sample one is the 0.065, rounded to 2 decimal places, which should be 0.07. Okay. Part B, on the basis of the histogram on the right, comment on the appropriateness of using the empirical rule to make an in general statement. So empirical rule applies when you have a bell-shaped curve. And then this one is approximate bell-shaped. So yes, the histogram is bell-shaped, so the empirical rule can be used. Okay, how do you use the empirical rule? Okay, look at the standard deviation is 0.07. And if you find out the mean is 0.84, if you look back onto what our calculation here, you'll see the mean is actually 0.84 here. And then they gave you this in your question. So one standard deviation above will be 0.84 plus the 0.07, which will be giving you 0.91. But which is not the 0.98, but if you add 2 standard deviation, that will be 2 times 0.07, give you a 0.14. Add the 0.94, you get exactly 0.98. So that means 0.98 is 2 standard deviation above the mean. Do the same thing if you have 0.84 minus the 2 standard deviation, which is 0.14, then you should get the 0.7. That means 0.7 and 0.98 is 2 standard deviation below and above the mean. That, by empirical rule, should give you a 95%. Okay, determine the actual percentage of the candies that weighs between this, including 0.7 and 0.98. So in this question, actually you need to look at the data and to see how many of the numbers are between 0.7 and 0.98. So if you go back here, if you go back here, look at that. How can I decide how many are between those two numbers? Okay, you have an easier way to do that is first under data, sort it. Sort the variable. Okay, now it's easier for you to see how many is between 0.7, okay, and 0.98. So if you look at this, 0.71 is the first one, actually is already bigger than the 0.7, all the way until when you find out 0.98. Let's see, go down. Okay, 0.96 is less than 0.98, but 0.99 is already bigger. So total, you actually have 48 numbers out of the total 50. That will give you the percentage. So you should do 48 divided by 50, which will give you a 0.96. That means it's 96%. So that's Part C is based on the empirical rule, has an approximation of that, but Part D is based on our sample. We actually got 96%. Part E used the empirical rule to determine the percentage percentage of candies with weights more than 0.91. So 0.91 is actually 1 standard deviation above the mean. If you remember empirical rule, the middle part is 68%, and then the symmetric, that means if you 1 minus 68%, give you a 32%, that will be including 1 standard deviation to the left and 1 standard deviation to the right. But I want the value to be bigger than the 1 standard deviation. So 32% divided by 2 will give you 16%. So if you want to be greater than 1 standard deviation, that should give you a 16%. Determine the actual percentage of candies that weighs more than 0.91. So this is from empirical rule, this is from your sample. Then the similarly, you can look at the data and see bigger than 0.91. You will have 44 will be smaller than or equal to that left 6 numbers, which is bigger than the 0.91. So you use 6 divided by 50 should give you the percentage. So 6 divided by 50 give you a 0.12, which is 12%. Okay, so that's how you look at the set of data and then comparing with the empirical rule.